Okay, so Amr has a really good question. Amr, the relationship between mass and volume is important for density. Okay,
Yes.
so,
Okay.
okay,
Does
okay.
somebody have
For
a curve?
example, no, guys, I think they're testing something in the school.
Yes.
For
Yes.
example,
Tracing curve.
yes, okay, guys, finish now with the noise in the background. The density doesn't change because it's related to the mass and volume of this object. For example, the water will never change its density. It will always be heavier than oil, for example. Have you ever tried mixing oil and water together?
Yes.
Yeah.
Yes.
Yes,
Yes.
a lot.
Yes. You tried
Yes,
mixing
we had
them,
a
but
project
they never
we
mix.
had a project
Actually,
once
the oil stays at the top and the water stays at the bottom because
because
water is way
the
heavier.
water is more denser
Yes,
than
it's
the.
denser. Yes. So the question here says, yeah, different samples of the same substance can have different masses and volumes, but their densities are still the same. Yes, because if you change the mass, the volume will always change. I mean, now you have a cup of water, okay?
Yes.
Your cup of water is a small amount of water. Now compare this cup of water
Yeah.
to a whole bottle of water, like 2 liters of water.
It will be more heavier.
Yes, it will be heavier, but the density of the water will stay the same. I mean, will the cup of
Yes.
water, for example, mix with oil, or it will be denser?
It will be.
Miss,
It will still be dense.
Denser, yes. You
miss,
only change the mass. Guys, someone keeps saying miss, and
Yes.
that's really annoying. Okay, so stop saying miss until I finish what I'm saying.
Yes.
okay, so I just wanted to ask something.
Your voice is
Here,
going
Tanahi,
so
you
faster.
have to be a little bit patient. Every session I tell you that.
Yes.
Try to be
Okay.
patient, ya Tanahi. Okay, I'm answering a question for Amr because he was asking for something. Okay, Amr. So here
I
it's
just
telling you
joined.
that mass and volume are changing, but the density stays the same because if masses changes, the volume will always change. So it's kind of still the relationship between them. فاهم حاجة؟ يعني I didn't only change mass and volume stays the same. Mass and volume both
Yes.
will
You change
change.
both.
Yes, both change, so that means their density will stay the same. I mean by density here is the relationship between them or the ratio between them. For example,
Yes.
let me just admit some people.
Okay.
Okay, so here maybe
This is
we have
this is
one, yes, a water with 1 mass and 2 as a volume.
Miss.
Okay, yes.
I'm here.
What should I do? Should I like clap my hands for you? Okay, I know you're here. Thank you. I didn't take names yet. Thank you. You have to wait. Do not interrupt the session. Okay.
Because I
1
thought
over
that
2. 1 over 2 is the density of water with 1 as mass and 2 as a volume. Okay. Now we change them. Yeah. For example, I get the same substance. Okay.
Yes.
2 as mass. Its mass got bigger. So its volume will always get also bigger.
Bigger.
Yes, stop. Can you يعني I don't know what do we call this in math, like subtract or something, like get this 1, it's gonna be 1 over 2, صح?
Divide. Yes.
Yes, it's still the same density.
fraction.
So both of them are different masses. Mass and volume are different. Not the same as this one.
Yes.
Miss, but it's still half. Like it's still half.
Still what? Yes, still
It's
half.
still half.
Yes, Habibi, yes, I know. That's what I mean. The ratio is still the same. The ratio is still the same. Yes, that's what we mean. The ratio is still the same. Though the mass and the volume changed, the ratio between them is still the same. Yeah,
Is the
that's why density doesn't change.
Miss, but
Because
there
if
is like
mass changes, the volume will always change with it. So the relationship will stay the same. That's what we mean.
You can't only change mass or you can't only change volume.
Yes.
you must change both.
Both of them will change together. This is what we mean. Okay?
Okay.
Did you understand it now?
Miss, but
Yes.
if I okay, I understand.
Yes,
Okay.
Tanahi. Yes,
I wanted
Tanahi.
to no nothing. Thank
It's
you.
okay. It's okay, huh? What do you want to say?
I wanted to ask why when you put like nothing سؤال غريب غبي شوية.
لا هو مفيش أسئلة غبية بس هو يعني is it strange that we do not need or is it strange that is still related to what we're saying?
Not needed.
Not.
Okay, if we have time at the end, you can still ask this question. Okay, now let's move to
Okay.
chapter 14, lesson 2. Okay, so in chapter 14, lesson 2, we learned about physical properties and changes. In chapter 16, lesson 1, we learned about chemical properties and changes. That's why those two lessons are so related together. Yeah. So in chapter 14, lesson 2, what are physical properties? A physical property is something that you can see yourself, like a change that you can see or sense, okay, not like chemical one. And it doesn't produce a new substance. For example, you have these papers on the right. Okay, I crumped them, or they are crumped, but they're still paper, right? Did they change into oil, for example? Did they change into oil, for example, everyone? No, still
No.
paper. Yes. This is what
No.
we mean by, yes, physical change. So what is a physical change? Again, it's a change, but in which substance or the matter is not going to change into another thing. It's still the same.
It's not gonna change forever.
Yes, but just,
Hmm.
changes the shape, maybe became smaller. If I cut paper, I'm cutting it, but still paper, right? Didn't change totally into a whole new matter. Okay, the process that cause physical change are so easy. Could be melting, boiling things, condensing, or freezing them. Melting, for example, like when ice melts at 0 Celsius, it's now turning from solid to liquid, right? It's now changing from solid to liquid. So it's still water, or did it just became something else? Still water,
It's
right?
still water.
Yes.
Yes.
When I boil water, liquid water, I start boiling it. I'm turning it into gas now. It will turn from liquid to gas. Did it change? It's still H2O, or did it change?
It's still H2O.
Still H2O, but only changed its state or its shape. يعني it
Shape.
became, yes,
Yes.
it changed from liquid
Changing
and
shapes
became
only.
gas. Yes. Now the other two processes are condensing and freezing. Condense is kind of the opposite of boiling. When you boil things and you turn them into gas, you can change them back from gas into liquid, and this is what we call condensing or condensation.
Condensing.
Condensation, yes, condensing. You're supposed to know this from grade 4.
Condensing. I thought it said densing.
No, I said condensing. Condenses. Okay, so yeah, as it condenses, it turns from liquid to, it turns from gas into liquid water. As it freezes,
Yes.
it's the opposite of melting. It's the one changing from liquid into solid. So these processes help in physical changing. Here is another example. Okay, so you'll see here, from liquid to solid, it's freezing. From solid to liquid,
Evaporation.
it's melting. From liquid to gas, it's evaporation. From gas to liquid, it's condensing. Then we have something else. From solid straight to gas, from solid straight to gas, like dry ice, it's called sublimation. And the opposite, it's deposition. But those are two things that you are new for this year.
For knowledge, right?
Yeah.
Or,
Yes. 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 You learned sublimation this year. Okay, so when I say melting, freezing, boiling, those are only process that changes the state of the matter. But what when I say melting point? Melting point. In this case, we're not saying melting point is like changing into from solid to liquid. No, it's the temperature. The temperature at which it's going to change.
Yeah.
Yes.
Be
So,
below
for
zero.
example, the
Below
melting point for the water and freezing point are still the same. I mean, the water changes into ice when it becomes 0 Celsius, at temperature of 0 Celsius. And the ice becomes liquid at also 0 Celsius. Because it's inside the freezer, and freezer is actually below 0, so that's why it's kept ice.
Melt.
But once
There's
it
something
gets out,
called
it will actually
melting
have...
point.
Yes.
There's something called melting point.
احنا مش أول مرة نقول melting point على فكرة. Melting point, guys, is the temperature itself. Melting point is the temperature. Okay, the temperature at which the solid turns into liquid. Freezing point will also be the temperature, but at which the substance changes from liquid into solid. You get it now? Everyone? Do you guys get it?
Yes.
Yes, yes.
Everyone else?
Yes, yes, miss.
Yasin is Sadat. I will kick you out of the session
Yes.
if you keep doing these strange voices. Okay, Yasin?
Okay.
100 Celsius, for example, is the boiling point and also the condensing point. Yani when water reaches 100 Celsius, it will change into gas. And when the gas shape of the water or the water vapor reaches 100, it will actually get back to being liquid. What I need you guys to know from all of this is that melting point, if I'm saying point, after the process, that means I'm talking about the temperature itself, okay? Okay, everyone?
Okay.
Yes. Then we had sublime, and sublime means to change from solid directly into gas. This is dry ice. Can you guys see? It's not melting into liquid water. It's actually changing totally into gas. Can you see that?
Yes, miss.
Yes. So this is what we call sublime. Yes. Okay. Okay. Now we learn about density, and density is how closely the particles of a matter are close. Can you see this? Atoms are the smallest possible particle of the matter. Like the smallest part of the matter is called atom. How are they arranged together? This is what we call density. Or we can say it's the relationship between mass and volume. Can you guys see that? Can you see the particles here, for example?
Yes. Away
As
from
they
each
get
other.
As they get closer, the density increases, which means they become heavier. So if we imagine this is the gas shape of the water, this would be the solid shape of the water. Okay? What is density? It's mass divided by volume. Mass divided by volume.
Mass divided by volume.
Yes, mass divided by volume. Okay?
Miss, we use math in science.
Well, math is included in all science parts, yes.
Okay.
Okay.
No, I didn't expect that.
The larger the volume, the bigger the volume, the less the density. And the bigger the mass, the bigger the density. All I want you guys to understand from this point is that density is related to mass and volume. That's it. Okay? Okay? Okay, everyone?
Okay. Okay,
We already explained this part before. Then we have mixture and solution. What is the difference between mixture and solution? I want you guys to look at this picture of some vegetables together and look at this picture of me mixing salt with water. Which one is solution and which one is mixture?
Miss, I know.
Mixture, I think it's the
Mixture
veggies.
is
I know mixture. You can get the
Is the-
two things out from each other.
Well,
I think
solution
They are stuck
is
forever.
also, it's kind of a mixture. But the difference between mixture and solution is that in the mixture, sometimes you can still see the parts of this mixture. For here, you can see the beans.
Like fruit salad.
Solution you cannot see.
In solutions, all of these things are mixed evenly. This is a very important word.
Like
Are
you cannot
mixed,
see.
yes, are mixed evenly. You can't separate them together. Yeah, you can't see the
Miss,
difference.
can you get a picture of the solution?
This picture,
Miss,
can't
but
you
the
see it?
solution is a mixture. The solution is considered a mixture, like they are alike.
Yes, it is a mixture.
Excellent.
Yes, we have different
Very-
types of mixtures. Guys, we have different types of mixtures, okay? But the big difference between when I say mixture with parts, obviously, we can see them, and solution is that in solution, you are mixing things together, but you can't see them because they are mixed evenly. They are mixed evenly, okay?
Even
once-
permanently.
Yes, not permanently because you can separate them later by evaporation, but evenly. You can see the difference between the different parts. Yeah, you can see the sugar and the water separated. Yeah, you know this
I
water
can see it.
sugar. You know the water is filled with sugar, but you can't see the sugar in its particles. You just start
Yes, and sodium and calcium and everything.
Yes, and other things that dissolve in the water. Okay, the physical changes again are changing the matter, but only in shape, not changing it totally. Like cutting, breaking, crushing, bending, melting, freezing, boiling, recycling is a physical change. There was a question saying recycling isn't a physical change. This is a wrong question. Recycling is a physical change. Netting a sweater or painting. So you have different examples here also. So let's go to lesson 3 so we can do the worksheet. I think maybe we'll do the worksheet tomorrow because we don't have enough time today. But we'll see. Okay, in chemical change, it's changing into a whole new matter, not like physical change. Okay, for example, here I'm cutting the wood, so that's a physical change. But when I burn the wood, can I bring it back to its normal or its formal shape?
Impossible.
Yes, and
You can.
it's not wood anymore. It's actually carbon or wood that's burned, burned, and this black part is called carbon. So it's
Miss,
yes.
and also it burns when carbon dioxide attach with the oxygen. Yes.
Oxygen goes through chemical
Oxygen is flammable.
Oxygen through chemical.
Yes. Burning actually
Oxygen.
is fueled by oxygen.
Yes.
Yes,
So
because
what's the
when you
chemical
burn
change?
something, the
Because
oxygen
of that, we have nitrogen more than oxygen.
That's why we have
in the
nitrogen.
air.
That's nice. You guys
and miss,
still
because
remember this.
also this, and because also that the I know it in Arabic الفحم.
أيوة.
It's not good to use it because
Cool.
when we burn it,
No, why? Who said
it
it's not
comes
good to
out
use it?
carbon dioxide.
It
Okay,
makes
you will
steam, bad steam.
get. No, but you need it in cooking.
Yes,
Just
but
don't
when
use
we
it.
burn it a lot,
You can use the steam, the heat coming
Maybe-
from it, but don't put it
but
between
not
the
a lot.
food. Some people
No.
get coal أو الفحم ده وبيحطوه مثلا في صينية أكل مثلا.
ايوه
تمام؟
لا ده
This
عشان
is
يدوا الاكل طعم.
this is unhealthy condition. But you can use coal in order to cook things. تحرقه عشان تستغله انك تطبخ فيه حاجة.
Some people use it in
انت تحطه في
electricity.
الأكل ده غلط. Okay?
Some people use it in electricity.
Yeah, some people actually produce electricity with.
They use
So
coal to make the trains move.
we have two
Yes, and to
different
make
examples
fire.
here. Guys, look at this picture, please. We have 2 marshmallows, right?
Okay.
One marshmallow just was heated enough to melt only. We didn't burn it. We just melted it. In this case, it's still marshmallow. It didn't change.
Yes. Will
Yes.
cool down again and become a marshmallow again.
Yes, that's right. But if I burn it up here in this picture, you can see now it's burning. Yeah, it's changing into a whole new substance. In this case,
burning, but if you melted it.
You're not
You can
melting
melt
it.
it.
Here you're burning it. And here
You
you
can burn it, you
melted.
can melt it.
ما هو اكيد الاثنين هيحصلوا يا طناحي، اكيد الاثنين هيحصلوا مع بعض. But sometimes you don't have to leave it till it burns.
Until it's black.
ماشي. If it's black like this, you burn it. If it melts, it needs to be with no black colors on it. But if it's burned like this, that means it changed. يعني this black substance is not marshmallow anymore. It's actually carbon.
Carbon?
Yeah, carbon. Yeah.
Carbon?
Yes. Okay.
Miss, when the color change, so the changing of the color is a physical change or a chemical change?
Well, it's a chemical change. It's like most of the time is identification for chemical change, but not all the time. Because, for example, when you mix tea with water, this is not a chemical change. You still have those separated, but just change the color of the water. Yeah, but it's not a chemical change. It's a physical change. So change of coloring is not always a chemical change. But most of the chemical change have a change in the color. Okay, so melting is a physical, while burning is a chemical. Then you have two other things, examples of chemical change. First one is combustibility, which is the measure of how things can burn or combine with oxygen. And corrosion, which means, someone said it before, like rust, how things or metals also combine with oxygen. So in combustibility and corrosion, both of the materials will actually combine with oxygen. But combustibility means that they combine with oxygen in order to burn up. But in corrosion, they are combining with oxygen, but to form rust. Okay? To form the rust. The last thing is reactivity, or the ability of the substance to actually go through the chemical change. And some substances do go through chemical change really fast. For example, gold and iron. Gold and iron. Okay? Gold, his reactivity is really low because that's why it doesn't go through rusting, and it doesn't rust or doesn't combine with oxygen so fast. But iron, its reactivity is so strong. That's why it combines with oxygen and starts rusting. Guys, I'll have to end the meeting right
Miss,
now.
what is metabolism?
Metabolism, eating, breaking down the food in your stomach.
Yes.
Okay, guys. Okay. So tomorrow we will do the worksheet, and then we'll do our revision sheet also. So please try to study today, chapter 14, lesson 2 and 3. And tomorrow we'll do a worksheet for them, and also a revision sheet for the whole chapter, for chapter 14. For the whole chapter 14, okay? Okay, guys?
Miss, we still have 10 minutes.
Okay.
I know,
Okay,
but
Miss
I will
Buzz.
have to leave a little bit early because I need to prepare some papers for the exams.
Okay, Miss, bye.
Okay, do you guys need anything?
Bye.
Bye.
Bye. Bye.